The animal kingdom is designated into three groups: the meat eaters, which are carnivores, the plant eaters, which are herbivores, and omnivores, who eat a bit of both, each with different sets of teeth that are necessary for individual dietary needs and survival, specifically shown through the distinct physiology between carnivores and herbivores, for example the gorilla and saber-toothed tiger.
The Smilodon fatalis, more commonly known as the saber-toothed tiger, is one of the most easily recognizable prehistoric predators, mainly due to their easily distinguishable large canine teeth. These two very long canines that extended past the bottom jaw have captivated paleontologists for years and raised several questions about the behavior of these unique animals. Questions such as, how did they hunt and kill their prey? How big were their prey? Were the canines just a display of dominance, maybe a way to get a mate? It is certain that their teeth are essential for chewing, to digest food properly, and keeping a steady jaw, just like most other animals. However, the saber-tooth is different to other animals as it adapted canines that grew up to 7 inches long, which were used to inflict a stabbing death blow to their prey. These canines develop after the loss of baby teeth, right before they enter adolescence, and they grew at a rate of 8 millimeters a month for more than 18 months. These fascinating creatures lived 2 million years ago in both North and South America and only became extinct about 12,000 years ago, at the end of the late Pleistocene in the Quaternary extinction. They were the apex predators in their environment, but they hunted mainly on mammoths and giant ground sloths. To take down such large animals required one fatal wound, generally to the jugular or abdomen, and the saber-toothed tigers had just the right teeth for the job. The saber-toothed tigers specialized in attacking very large prey. As a result of their unique teeth, incisor and carnassial morphology indicates extreme flesh specialization and the lack of bone-crushing ability. Saber-tooth cranial morphology and fossil associations suggest a specialization upon very large prey.
Now, compare all of these things to that of a gorilla. Unlike the saber-toothed tiger, gorillas are herbivores and do not eat or hunt other animals. This means that their diets differ quite immensely, as well as their teeth structure. While the diets of gorillas will vary slightly between each different subspecies, as a result of the different niches they inhabit, their morphology remain much the same, meaning that so do their diets. Overall, gorillas consume large quantities of foliage and a diverse range of fruits throughout each day. This is clearly different to that of a saber-tooth, as the food in which they consume possess a different weight, density, and solidity to that of a gorilla. The consumption of food for gorillas requires large, strong teeth, specifically molars and premolars. The enormous jaw cavity of gorillas are filled with 32 teeth, with the main common characteristic from early primates being their teeth structure. While this is true, gorillas today have much larger and more robust teeth, which are now better adapted for the use of grinding up coarse foliage and fruit into easily digestible pieces. Yes, gorillas do also possess large canines. However, this is most commonly seen in carnivores, and in this instance the saber-tooth, which uses their sizable teeth to rip and tear through the carcasses of prey. So why is it that gorillas have large canines if they do not consume meat? These teeth are not used for hunting, but more for defense and intimidating rival males or potential predators. On the off chance that a gorilla is attacked, they will use their canines to fight back. It is also suggested that their canines were an adaptation passed down by early primates due to the harsher living conditions. Although in today's environment gorillas don't need them, they still occur due to the long period of time that it takes for a mutation to disappear from the gene pool.
The significance of these facts reveals that the act of chewing and devouring food is different for each species, and is most likely the reason for different jaw and teeth structuring between carnivores and herbivores.